of the game? Yeah, not quite as many hands as were. I didn't either. So, but it was a close contest, ladies and gentlemen. Hip and tug. Finally came out on top, 58-0. A good beginning for sure. Hey, any WebAssign questions or frustrations or yes, sir?
I tried to log in. I received my little thing on the mail.
Oh, good.
But I feel like they didn't give us spaces to put the access code in here.
Okay.
So when I kept trying, it's like a space short.
Where did you go to log in?
I don't know if I did it right.
Okay.
I did the little pre-thing, the little.
First page, the key.
I have it with me. We can show me after class.
Okay.
That's it.
Had you already signed in with the key to?
Yeah, I already
You had a password and. So did you log that in and go to the page?
I just followed the little directions on the page, on the little thing that, that I got in the mail.
Okay. I think that might have had too many instructions. What you're going to want to do is go to, I think, basically the second or third page, and it'll have options for paying, and you'll click on the one that says, I do have a code.
Yeah, I did that, and then it asked me to type it in, and then I did, and then it kept saying that it wasn't the right one.
Okay. Well, let's look at that. Yeah, let's look at that class. Anybody else have a similar experience? We'll check it out. All right, today, ladies and gentlemen, we're going to take some notes about, we're going to enter into section 2. This is the section that you actually have homework on. So we're going to start talking about exponents and radical expressions. We hadn't talked about exponents and radical expressions before, right? And I got to warn you, ladies and gentlemen, I went to school in the 60s, so I'm very familiar with the radical expressions. Like, make love not war, don't trust anybody over 30, or peace. So we'll get some other radical expressions too, but let's start with exponents. And we're going to start off easy. We're going to look at exponents in some incremental steps. We're going to start with positive integer exponents, which is stuff you're familiar with, stuff you first encountered when you encountered exponents. Stuff that looks like this. You see a value and then this little superscript, this little raised number. And we know that these values have, these parts have names. The 3, for instance, could be called the, or the,
power.
Either one. Exponent or power, either one. And we will be referring to both those, so. By the way, what's the x called in this case?
Base.
The base. Very good. The thing raised to the power is the base. And you know, with a positive integer exponents, that a base raised to a power simply means the base is used as a factor. When I say factor, what operation am I talking about?
Multiplication.
Multiplication. So the base is used as a factor, the exponent number of times. That's basically what it means. X to the 3rd power, or x cubed, or x with a little superscript of 3 means x used as a factor. All right, let's look at this guy. And one of the key questions you're going to have to ask when you see an exponential expression like this is, what's the base? So how many would go with 2x as the base? How many go with x as the base? The other 50 of you, what would you say? I saw those hands that didn't go up. You realize that makes a difference, don't you? Yeah. You realize that if 2x is the base, then 2x to the 3rd power means the base used as a factor 3 times, right? If, however, x is the base, this means 2 times x used as a factor 3 times. This gives me 2x3 when I simplify it. This gives me, be careful,
8x to the third power.
8x3. By the way, somebody multiplied 2x times 2x times 2x. Somebody? How did you get 8? Can you explain to me? Yes, ma'am.
Because 2 times 2 is 4, and 4 times 2 is 8.
Yeah, but there's an x in between those two.
And then you multiply the x times x times x, which is x squared.
Well, wait a minute. Did you move stuff around?
Yeah.
What gives you the right to multiply those 2's together and then multiply the x's together? What gives you the right to do that?
I mean, they're not.
What gives you the right to re-express this as 2 times 2 times 2 times? That's what you did in your head, isn't it? Isn't that what you did in your head? Just because you did it in your head doesn't mean you have a right to do it. What gives you the right to do that? Thank you very much. Yes, commutative property, ladies and gentlemen. Commutative property for multiplication says I can move stuff around that I'm multiplying anytime I want to. And you wanted to, didn't you? So you wanted to multiply those 2's together, so you put them together. You did it in your head. You didn't do it on paper. Doesn't matter. You move stuff around, got 8x to the third power. Correctly, by the way. Good job. All right, we got to decide which one of these is correct, because obviously I get 2 different answers. And here's the rule of thumb we're going to use. You ready? The base is that factor immediately adjacent to the exponent. The base is that factor immediately adjacent next to the exponent, unless parentheses tells you differently. Got no parentheses here, so the base, you're absolutely correct, is the x. That's my base. Which raises the question, then, what's the 2?
Coefficient.
Coefficient. Very good. Coefficient, an ancient Greek word that means the number that goes along to the right. Actually, that's what it does. The 2 basically just kind of goes along to the right. The x is the thing raised to the third power. And you remember, please excuse my dear Aunt Sally, right? I do the exponents first, then I multiply by the coefficient. So keep in mind, recognizing what's the base, what's the coefficient is going to be important. Hey, what if I wanted to make 2x the base? Parentheses. So if I want 2x to be the base, I can very simply bring that about just like that. 2x is now the base. And that does mean 2x times 2x times 2x. And the commutative property of multiplication says that is going to be 8x to the third in a simplified expression. You want a challenging one? That's rhetorical. You're getting one in. Here it comes. I want everybody to write down an answer. Do not say anything out loud. Write down your answer, please. A strong impression. The answers you got are either 16 or negative 16. Am I right?
Yeah.
How many of you got 16? Positive 16. Look at those hands. Those are proud hands raised. How many of you got to negative 16? A few hesitantly raising their hands. Sorry. You're correct. Negative 16 is correct. Hey, here's the question. What's the base? 2. You get figuring this out now, right? Remember the rule of thumb. The base is that factor immediately adjacent to the exponent, unless parentheses tell you differently. Well, it looks like negative 2 is the base here. I mean, I would get that impression. What would I do if I wanted negative 2 to be the base?
Parentheses.
Use those parentheses. So negative 2 to the 4th, you're absolutely right. That's 16. Negative of 2 to the 4th brings us back to, please excuse my dear Aunt Sally. 2 to the 4th first, 16. Make it negative, negative 16. This is negative 16, and will show up again. Hint, hint, hint. Hey, if 2 is the base, what's this negative right here? It's a coefficient. Coefficient of what?
1.
Negative 1. This is kind of a shorthand way of saying, negative 1 times 2 to the 4th power. That's basically what you're saying. Keep that in mind. That's going to show up often. By the way, negative 2 to the 4th. How'd you know that was going to be positive 16? Even what?
Even number.
Even number for your exponent, right? Are you familiar with that concept? That a negative to an even number, hey, if I gave you negative 1 to the 28th power, you could do that in one of two ways. Negative 1 times negative 1 is positive 1 times negative 1. You help me. Can I use your fingers too? Is negative. Got the idea? Or you could say, wait a minute, a negative to an even power is going to be positive. So I'm finished. Got it. And likewise, negative 1 to the 123rd power is going to be negative 1. Negative 1 is to an odd power. So you have this general observation. A negative to an even number is going to be positive. A negative number to an odd power is going to be negative. Or you can think of it like this. An even number of negatives turns out to be positive. An odd number of negatives, and that's true for multiplication or division, turns out to be negative. Nice thing to hang on to, especially when you have something with a very inconvenient power. All right, we've got your positive integer exponent concept. As soon as you start talking about the positive integer exponent concept, you can introduce the properties of exponents. Consider some of the more familiar properties of exponents, like the first property of exponents. You're familiar with it. It says something like this. If I'm multiplying two exponential expressions that have the same base, did you notice that? They have the same base. That have the same base. What do I do with those exponents?
Add them.
You got it. And you won't write that down like that, but giving you the idea, it's extra clear. And should you ever forget that, you can go back to the basic definition of exponents. Hey, x squared simply means x times x times x to the third, or x cubed means 3x's. And look what you got there. You got 5 x's multiplied. We have a shorthand way of saying 5 x's multiplied, and that's how it's at. And you're going to be using this guy a lot. In fact, just about every time you multiply exponential expressions, you're going to be using the first property of exponents. Like, and let's throw in some coefficients just to make life interesting. And I need to remember, what do I do with those coefficients? The coefficients. That's right. So don't put all your operational eggs in one basket. I do two different things here. 3 times 5 is still 15, just like it was in 4th grade. Here's the new part. X to the 4th times x to the 4th is going to be x to the 8th. Add them up. Okay? Hey, I can throw in multiple variables. What am I going to get there? Are those parentheses messing you?
Negative 8.
Negative 8.
8 to the 3rd.
8 to the
3rd. B to the 8th.
Okay, how'd you get 8 to the 3rd? Because I don't see an exponent here, but I see this too. Yeah. You familiar with that? A is the same as A to the 1st. And if it helps you to remember, I will not be offended, ladies and gentlemen. You put a 1 right there, all right? If it helps you to remember to add the 1 to the 2, put it there. A is the same as A to the 1st. 7 is the same as 7 to the 1st. Okay, keep that in mind. We're going to be seeing that again a little later. Anything is the same as to the first power. All right? First property of exponents. Hey, there is likewise a second property of exponents. I'm going to call these guys the first and second properties just because they typically are the first and second ones you introduce when you start talking about properties of exponents. Now notice I'm going to use the same numbers, x's, 2's, and 3's, but notice the difference. Notice the difference between that and that. And when I have an exponential expression raised to a power, or what I'm going to be calling a power to a power, what do you do with those exponents? Absolutely. Multiply. And of course, you'd probably leave out that middle step, but just to remind us. And once again, if you forget this, go back to your basic definition of exponents. Something to the third power means the something used as a factor 3 times. But check it out. That's an application of the first property of exponents. Right? Same base. Add your exponents. 2 plus 2 plus 2. X to the 6. So, should you forget, go back to the basic definition of exponents and remind yourself. Time is flying. It's almost 9:30. We better hurry. It's going to be a long period, ladies and gentlemen. You get that feeling? Tell you what, somebody kind of go like this when it's about 5 minutes till time, all right? All right. Let's do some applications of the second property of exponents. Once again, this is something I'm going to call powers to a power. When I have powers to a power, what do I do with those exponents?
Multiply.
You multiply. Now, here's something you can do. By the way, what's the coefficient of this guy going to be?
2.
2, right? And the final answer? 2, right? 8. There's a question. All right. Here's what you might want to do, even with your coefficient. Put everything to a power. Remember, 2 is the same as 2 to the 1, our first power. Now, basically, what you're doing is multiplying all your exponents by 3, right? So, before we simplify, this is going to be 2 to the 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. Right?
Mm-hmm.
That's 8. You're correct. 8, x6, y9. Even the 2 is raised to the third power. Keep that in mind. Try another. Is my answer positive or negative?
Negative.
Absolutely. Negative number raised to an odd power. Negative what? Very good. What else? A what?
Third.
Good.
B to the 9.
Very good. And if you wanted to, you could re-express it like that, a to the first. Just to remind yourself, hey, how to multiply that by 3. Let's go back to the first property of exponents for just a second and look at this example. This is again an application of the first property of exponents. It's not a power to a power. It's an exponential expression times an exponential expression. Somebody want to tell me what you get here?
X, Y.
X y to the 7. Can we go with x y to the 7?
X, Y, 7.
I'm sorry? And you get x to the third, y to the fourth. Does that mean you're kind of lazy on this day after Labor Day? You don't want to work? Just write it down. How many would agree it's just x3, y4? You've got some. Why didn't you combine the exponents?
Because they're not the same base.
Bases are not the same. Bases are the same as when I combine the exponents. Don't be sucked into the opportunity to combine exponents when you're not allowed to. This, ladies and gentlemen, says do not combine exponents, different bases. X3, Y4 is as simple as you can write this. Absolutely correct. Keep that in mind. That's important. All right. Positive integer exponents. First and second property of exponents. Now let's move to 0. The next one. We looked at positive integer exponents like 1, 2, 3, 4, 5, 6. Now let's consider what happens when I have 0 in the next one. Some of you are already aware of what this is. Most of us are going,